All right, LeetCode 409, longest palindrome. This is a bit of a tricky problem when you first look at it, but basically given the string s, and it has a bunch of random lowercase and uppercase characters, and you want to return the length of the longest palindrome that you can form with those letters. I think a lot of people see the actual palindrome being formed, like they in this example, they see D, C, C, A, C, C, D, and like, oh, well, how am I going to form that? When in reality, the only real output is the length itself. And once you kind of realize that and realize that the only thing you care about is that length, this problem becomes a lot easier because it becomes a game of the interaction between the odds and the evens and this idea of symmetry. So let's pull up Paint and see what I'm talking about here. So let's look at example one, right? So S is equal to the string A, B, C, C, C. Is that four C's? Let's assume it's four. D, D, cool. So this is going to be our string. Well, in the example, it gives us that, okay, well, the longest string, the longest palindrome we can form is going to be of length 7. So it's D, C, C, A, C, C, D. Okay. Well, how do we form that? What's the logic that we use? And right away, I'm just going to say it. We're going to be using the idea that we can count the occurrences of characters in a string, right? So again, we're coming back to the idea of a hash map. So let's do that right away. So let's say A, how many A's do we have? We have one A, right? Cool. B, how many B's do we have? We have one B. Cool. How many C's do we have? We have, let's say 4, right? How many D's do we have? Well, we have 2 D's. Cool. So let's set this away for just a second and let's look at this idea that we talked about of this interplay between the odds and the evens. So let's say I have an even palindrome, right? So AA, right? This is an even. So I'll say like case even. And let's consider that I have no more A's that I can add on to this string, right? I'm done. I used up all my A's, right? In that count that we did, we don't have any more A's. What can I add to this to make it, to keep it a palindrome, right? Because right now we know it's a palindrome. So let's say we have like a letter B, right? If this is even, this is an even length palindrome, what can I do? Where can I put this B to keep this a palindrome? Well, I can put it in the middle, right? I can make A, B, A, right? So that's the case that the thing that we're adding an odd amount of things. But what if, let's say we're adding an even amount. What if we have two B's? That's an even amount of B's. What can I do with this? Well, like similarly as the previous example, I can just take a B and I can put each on each side, or I can just take a B and I can, let's say, do like this, A, B, B, A, right? This is also a palindrome. So the thing I'm trying to say is that when we have an even length palindrome and the current letter we're at is not the letter we're adding, so like we're adding B in that other case, we can add an even amount or an odd amount of that other letter, and we will still have a palindrome, right? So it doesn't matter. We can just add on whatever we want. But let's take a look at like the case of an odd palindrome. So let's say we have AAA, right? This is an odd length palindrome. Well, in this case now, it gets a little trickier. So let's say again, we have our letter B, right? We're assuming we have no more A's to add, right? Because if we did have an A, we could just add it here, but that's not going to be a problem in our world, as we'll see in a second. So we see this, right? What can we add this at all to make this a palindrome? No, we can't, because this will break. No matter where I put this here, I put this here, I put this here, it just doesn't work. It doesn't become a palindrome. Likewise, if I had three B's, where can I put these three B's to make this a palindrome? Well, can I put two B's here and one B here, right? Or can I like do like one in the middle, one here, right? This just doesn't become a palindrome no matter what I do with the odds. So in case of an odd when you have an odd length palindrome, the only thing you can really do is we can only add an even amount of similar letters to turn this into a symmetrical, right? Because palindromes have this idea of symmetry. So let's say we have like two B's now, right? An even amount. Well, with this, I can just add on to the ends and boom, right? We have a palindrome again. Symmetry is preserved. So that's pretty much the idea. It's going to be this dance. We're going to be going through our counts, right? So our initial length of our palindrome is going to be 0, right? And we're going to be going through, right? So we're going to say, okay, well, 0, let's consider that even, right? So we're currently considering A. How many A's can I add to keep that 0 length thing a palindrome? Well, I can add all of them, right? Because if we have an even length palindrome, we can add whatever we want. So we're going to add all the A's. So now we have a palindrome of length 1, right? It's going to be an odd length palindrome. Well, okay, can we add a B to it? Well, no, we can't, because AB is not going to be a palindrome. We're adding an odd thing to already odd thing. That's going to break this kind of symmetry we have. So we still have a maximum length palindrome of length 1. Let's look at C. We have 4 C's, right? And since we have 4 C's, that's an even amount, and we currently have a case of an odd palindrome, right? It's just A. Well, I can take those C's and I can add 2 here and add 2 here. Cool. And then I go on to D. So I have a 1, 2, 3, 4, 5. So my current palindrome is still of odd length, right? But I have an even number of D's, so I can just put them on the end. So there we go. D, C, C, A, C, C, D, just like we wanted here, right? And that's basically our logic. I know I kind of rushed this, but I think we can look at this in our code, and I'll try to make up for it by commenting the code quite a bit. So let's do it. So let's say int result is going to store the length of our longest palindrome, right? So we'll keep that as 0. And like we said, we want to count up all the characters we have in the string, right? So we're going to say, we're going to make an unordered map that's going to map from a character to an integer. And we'll call this M. And we'll say for, we'll pass this in by reference. So every character in the string S, we're basically just going to say M C is going to equal to 1 plus. Cool. So we'll do that. And this is going to give us the count. So let's just comment this in. We'll say get the count of every character in the string S. Cool. Now, what else do we want to do? We now want to go through everything we just counted up, right? So we're going to say for, let's say auto X in M. And just for reference, X is actually a pair. So we're going to go through every pair of this pair here, a character and its respective count. And so we're basically just going to say, we're going to ask ourselves, okay, what's the current length of our result, right? Or no, we should say this. We should say, is our current length, is it even or odd? So we're going to say, okay, if res mod 2, if that's equal to 0, then what did we say earlier, right? If we have an even length palindrome, we can add anything we want to it, right? So we can just say that res is going to be plus or equal to x dot second, right? So we're taking the count, x dot second represents that integer count, right? So we'll comment this in. So if the current palindrome, can't spell today, is even, we can add anything. Cool. Else, right? We're going to say else, the current palindrome is odd, right? So what do we do if the current palindrome is odd? Well, let's think about it. If x dot second modded by 2 is equal to 0, so if it's even, right? So we'll say if the character we want to add occurs evenly, we can just add it, right? So that means that we'll do res plus or equal x dot second. Cool. But what if, right, else, what if the character that we want to add, what if it's odd, right? What can we do if it's odd? You might say, well, we can't add it, we just skip it. But here's what we can do. What we can actually do is how do we turn an odd number into an even number, right? Remember, odds and evens alternate. So if we have something that's odd and we want to add that even number, what do? We just take one away, right? So let's say we have 3 characters, right? Let's say we have something like A, right? And we're considering C, C, C. So we have 3 Cs. I know I can't add 3 Cs to make this a palindrome, but the next closest even number is 2. So I can add just 2 of them, right? And still make a longer palindrome. So else, we're going to say res plus or equal to x dot second minus 1. And that should be it. We might have to do some error checking here later, just because if we go into the negatives, it might mess with our code. But I don't think there might not be any test cases like that on LeetCode. So let's run it. Cool, so that works. Let's run this. Cool, let's submit. Awesome, it runs. So let's talk about runtime complexity. Runtime is gonna be O of n, right? We go through the string once here to count up all the occurrences of the characters. And then we go through that map itself, which is scaling linearly based on the string itself. So it's O of n plus O of n gets you O of n runtime. Space complexity. This one's a little tricky because you can answer it in multiple ways. So some might say this is O of 1 space complexity, because if you look at the problem description, it says that S will only ever consist of lowercase and or uppercase English characters, right? So we know there's 26 lowercase English, right? There's 26 letters in the alphabet, right? And you multiply that by 2 because uppercase and lowercase, right? That's all you need to consider. So no matter how long our string is, the character map that we generate is only going to be of that size, right? We're not going to have like a character map of like 10,000 characters, because the only characters we're ever considering are lowercase and or uppercase English characters, right? So you can technically say O of 1, but if you're given this problem in an interview and it doesn't say this, I think a safe bet would be to say O of n, right? Because there are multiple languages out there. You could be given like some weird character schema, like you don't know. So it's, you could say O of 1 in this case, but generally I guess I would say O of n just to be safe. And that's pretty much all there is to it. I hope this helped, and thank you.